Hello everyone, welcome to a new video. Today we will look into the Python implementation of AIC and BIC, both of which we have covered in the previous video. If you haven't gone through it, I'll attach the link of the video and you can have a look. For today's exercise, we'll use the catfish sales dataset and we'll build a RIMA model out of it. And then we will look into the best possible or the most optimal RIMA model. We'll have multiple AR values and using AIC and BIC, we'll choose the best model. Let us start. The necessary libraries are pandas, datetime, numpy, matplotlib, stats models, and these are it. For an ARIMA model to work, it is necessary that the data is stationary. Now, how do we test the stationarity of a data? We perform the augmented Dickey-Fuller test. Over here we see the ADF or augmented Dickey-Fuller test is performed and we see the p-value is 0. That means that our data is stationary. If it wasn't stationary, we would have to perform differencing, which in turn would make it stationary. Differencing will cover in a separate video on time series. Now, what is stationarity? Stationarity is basically a feature in which the mean and variance of a series or a data is constant. That is, the mean and the variance doesn't change with time but remains constant across time. Since our data is constant or stationary, we can start with our model building. This is the plot of our data. This is the autocorrelation plot and this is the partial autocorrelation plot. So from partial autocorrelation, we'll get the AR values. So we see that the value of the PSEF is high at 1, then it reduces. Again, it spikes up at 4, followed by 6 and then by 10. So the possible values are AR1, AR4, AR6 or AR10. Now why 10 and why not 7 or 8? Because after 6 there is a drop and then again it spikes up. There's a drop, there's a further drop and then it spikes up again at 10. That's why we choose 10 and not 7 or 8. So let us build a model on this. So we form a list called AR orders in which we have the values of AR, that is 1, 4, 6 and 10, and then we loop over it and feed it into our ARIMA model. So these are the fitted models. The AR1 fit, AR4 fit, AR6 fit and the AR10 fit. Now, how do we identify the most optimal model amongst these four? First, we look into AIC. Now, AIC has a value of 2k minus 2l. L being the log likelihood, k being the number of parameters. So, as we know that the lower value of AIC is better, lower the value, the better the model is. L needs to be high for it to be low and k needs to be small. So, the model needs to be simpler with a good fit. So, we see that the AIC values are 1980, 1927, 1899 and 1902, out of which 1899 is the lowest and is corresponding to AR6. So based on AIC, we choose AR6 as the most optimal model. Now what does BIC tell us? So BIC basically is natural log of n into k minus 2l, where n is the number of samples used for fitting. That is, how many samples are chosen or how many samples are used to perform the fit. Again, the lower the value of BIC, the better, for which L needs to be high and log of n and the value of k needs to be small. That is a simpler model which fits well using lesser number of samples. Let us perform or implement BIC now. As we see, the BIC values are as follows, in which 1920 is the lowest, that is corresponding to AR6. So even according to BIC, The best pick is AR6. Now we see the functions of the inbuilt function for both AIC and BIC are very simple. That is the fitted model dot AIC and fitted model dot BIC. So these are inbuilt functions and we did not define them. This was a very small video on the practical implementations of AIC and BIC in Python. I'll attach the link of this notebook in the description box along with the link to the previous video in which I have covered AIC and BIC in details. I hope you liked it. In case of any questions, do not hesitate to comment and ask. And also, if you liked the video, do like, share and subscribe. Thank you and I hope you liked it.